Hi, my name is Ethan Nowaski, and this is the Week 3 Explainer video, problem 65. Question asks, on your first trip to Planet X, you happen to take along a 200-gram mass, a 40-centimeter long spring, a meter stick, and a stopwatch. You're curious about the freefall acceleration on Planet X, where ordinary tasks seem easier than on Earth, but you can't find this info in your visitor guide. One night, you suspend the spring from the ceiling in your room and hang the mass from it. You find that the mass stretches the spring by 31.2 centimeters. You then pull the mass down 10 more centimeters and release it. With the stopwatch, you find that 10 oscillations takes 14.5 seconds. Based on this info, what is G? So first, with all this information that's given to us, let's collect our variables with our givens and what we're trying to find. So we found it gives us that mass is equal to 200 grams, which is 0.2 kilograms converted. The length of the spring is 40 centimeters, which is 0.4 meters. Our spring equilibrium length is 31.2 centimeters, or 0.312 meters. It takes 14.5 seconds to do 10 oscillations, and our max amplitude is 10 centimeters. And with that info, we're trying to find G, or the gravity. So how we're going to do this is we're going to first look at our equation. The force total is equal to mg minus kx is equal to 0. This is the equation for a vertical spring function when the spring is in equilibrium. So right now we can automatically say that we know the mass and we know our x, which is 0.312 meters, which might be surprising, but if you look back at our info, it tells us that when we put the mass on the spring, it comes down to 0.312 meters. So that's our equilibrium. You want to make sure that that is the x that you use in this, or else you're going to get the wrong answer. So with that information, we don't know k and we don't know g, but we can find k using this equation down here with period. And we can find period using another part of the problem that is given to us, which is the 14.5 seconds over 10 oscillations. And that gives us 1.45 seconds as our period. So with that information, we plug that value into our t for period, and we can plug our mass in for 0.2 kilograms. With that, we can solve for k by dividing the 1.45 by 2 pi, squaring it, and then cross-multiplying, and we get our k is equal to 3.75 kilograms per second squared. Now that we know k, we can plug that back into our original equation, which is 0 is equal to mg minus kx. Now, if we isolate the variable so we get g on one side, we get kx over m. Then we plug in our variables, which we found through the problem, and we get 3.75 kilograms per second squared times 0.312 meters over 0.2 kilograms. Now see, you can cross out the kilograms here, and that should leave us with the right measurement for our final answer, which is meters, right here, divided by second squared. And it actually gives us 5.85 meters per second squared is equal to g. So that's our final answer. The g is equal to 5.85 meters per second squared. Thank you.